All right, folks, get out your notes, get your homework handy. We're going to go through the warm up and the lessons. Shh. And yes, I said lessons. We're going to do 3 little kind of baby lessons today. Your homework tonight will be based on what the warm up looks like. Mia. Okay, we are going to talk about looking at a picture of a line and writing the equation. The 2 things that you need to identify when you're looking at a picture are slope and y-intercept, right? We're going to write our answers in slope-intercept form. There's other forms, but right now this is the form we use the most, and this is the form we're familiar with from last year. Y equals mx plus b. Your job is to identify the m, the slope, and identify the b. What's the b? The y-intercept, and then you can write the equation, replacing m with the slope number and b with the y-intercept number. So let's do this pink line first. Now, they won't always make nice big dots for you. You've got to look at the picture and figure out where it's crossing at some nice perfect grid lines. Okay, for example, one thing I know I need to identify is the y-intercept. Do y'all agree the y-intercept of this line is 2? So my job's half done. I know the b number. It's 2. To find the slope, though, I need more than just 1 point to find slope, because I've got to figure out how to get from 1 point to another. So I'm looking for some other nice, perfect lines, where it's crossing a grid line, I mean. And I can find some. I'm going to call these points A, B, and C. Now, when you're identifying slope, you always want to move forward. You can go backwards, but it's trickier. So, do I want to go from A to B or from B to A? I want to go A to B. You want to move forward. You want to always want to run to the right. Okay, now, to identify slope, you're looking for that rise over run relationship. And we always call it rise over run, but it could actually be fall over run, because you don't always go up. Sometimes you go down. That's what makes it a negative slope. Okay, so how would I get from point A to point B using that rise over run relationship? Yeah, I'm going to go down 2. That's why it's a negative slope. And then I'm going to go over 1, 2, 3. Down 2 and over 1, 2, 3. So what's the slope of this thing? Negative 2/3. So the equation of the pink line would be y equals negative 2/3 x, because slope goes in front of x, plus whatever the y-intercept is, which we already decided was a 2. Are y'all with me there? This is exactly what your homework's like. The homework should be pretty easy. You're looking at a picture, identifying slope and y-intercept, and then you're writing the equation. Okay, let's talk about going from A to C. Let's see if I went from A to C. I would go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. Going down 4 and over 6, what does that reduce to? Negative 2/3. Okay, so I'm going to get the same slope no matter what I do. Let's talk real quick about going backwards, because some kids try to go backwards, and you actually can, but you got to be careful. Let's say I want to go from B to A. How would I go from B to A using rise over run? I would go up 2, which is positive, but then I'd have to go backwards 3, which is negative. So that just puts the negative sign on bottom, which is no big deal, but I prefer it to be moved up to the top. So technically you can go backwards. You just have to be careful. And if it's a negative slope, I just like you to put the negative at the top. So do you feel comfortable doing that for homework? Because I think you did this last year. Did you? All right, let's do the brown or maroon line or whatever you want to call it. Red? Let's call it red. Okay. Again, we want to identify 2 important things, slope and y-intercept. Usually the first thing I do is y-intercept. What's the y-intercept of this red line? The b value of the red line is negative 1. Are we okay with that? Slope. Let's find some other points that are nice, perfect grids here. Can y'all identify the slope? Yes, you're going up 1 and over 2. Up 1 over 2. Up 1 over 2. So the slope of this guy is positive 1/2. So I identified slope and y-intercept. How would I write the equation? Y is equal to 1/2 x minus 1. This is exactly what I expect to see for your homework. So if you just put 1/2, that's not good enough. That's the slope, but that's not the equation of the line. Are you with me? Okay, the blue line. What's the slope of that blue line? 0. This one isn't rising at all. Remember, slope is rise over run. Well, to get from one point to another, I'm not rising at all. I'm just running. If you're just running, then that means you've got a completely flat line, and it means your slope is 0. Or 0 over 1. Okay, so yeah, we could write y equals 0, y equals 0 over 1. What's the y-intercept? -4. So our slope is 0. Our y-intercept is -4. How would we write the equation of this one? Yeah, we can even skip the whole 0x business, because 0 times anything is just going to be what? 0. So 0 times x is going to cancel the whole x completely out. Some people just really want to put that x in there. Is that the same thing? Yes, but I'm telling you, that's not how they're going to write the equation on a multiple choice answer. They're just going to put y equals -4. Are you okay with that? Okay, so basically that was part of your lesson today, which I think you had done that last year. Your homework, again, is going to look like that. I want to do a couple of other examples with you. For example, let's talk about one that does this business. And we're going to do this in a minute as well, with horizontal and vertical lines. Somebody said undefined. Something is undefined. What's undefined here? The slope is absolutely undefined, but that's just a fact about this line. It's not the equation of this line. Do y'all have any idea how to tell me the equation? Yes, this is one of those lines that doesn't follow the rules, and actually we're going to get to this in a minute when we talk about special cases. This doesn't even have a y-intercept, does it? If you ever get stuck, if you're not sure, look at a couple of points. If you're on a horizontal or a vertical line and you're not sure what to do, just name some of the points and you should probably start to see a pattern. What's this point right here? -2, 0. What's this point above it? -2, 1. What's this point above it? -2, 2. Let's go down here. That's -2, -1. Do you see something that they all have in common? They all have a -2 where? For the x. So guess what the equation of this line is? X equals -2. That's the equation of that line. Okay, and we'll do some more practice with that because we're going to talk in detail about vertical and horizontal. All right, you get your answer in your head. I'm going to draw a line. You see if you can identify the equation. Don't say it out loud. All right, now let's see how good I can draw a line. Everybody likes to make fun of my line drawing abilities. That was pretty good. I'm impressed with myself. All right, now see if you can get the equation in your head. Identify slope and y-intercept. This is what your homework's like. Raise your hand when you're ready to tell me the whole equation. One of the points is what? Oh, did I do something wrong? Yeah, let's just pretend like that one wasn't there, shall we? Okay, so what is the equation of this line, Chris? Oh, no. How does it start? Y equals. Don't forget the y equals. You got to have it. Then what? Okay, y equals what? Go ahead. 1/3 x plus 2. Do y'all agree with Chris? Yes. Please make sure when you're doing your homework tonight that you start with y equals. An equation must be that. It must be an equation. It must have an equal sign. Okay, let's do another one. Oopsie. Okay, here we go. That wasn't as good of a line as last time, but it's not bad. Mia, what's the equation of this line? Y equals, I do agree with the negative business. It's definitely going down, but I don't agree with -2. It's always rise over run. So let's count it out. From here to here, I'm going down 1 and over 2. Down 1 and over 2. So it's not a -2 slope. What is it? -1/2 slope. So y equals -1/2 x. Then what? -3. Very good. Are y'all okay with that? Good job, Mia. We're all proud of you. Okay, do we need to do more, or are y'all good with that? Because that's what your homework is. Okay, now moving on to the next topic. Get your notes out. We'll grade homework after. Okay, how about we get parent function out of the way, and then we'll talk about special cases. So we already did an equation from a picture. Now we're moving on to parent functions for lines. All right, we did this when we talked about quadratics. Do y'all remember what the quadratic parent function was? Y equals x squared. It's basically the simplest one you can make. The y-intercept is a 0. There's no b value. The b value is a 0. And the a value is a nice 1. We don't want to cancel everything out, so we had to let the a value equal a 1. Okay, well, with linear functions, the closest thing to a is slope. On a linear function, the value of a now really becomes the value that we call m. So I want you to think about the simplest linear function that you could possibly draw. It's not too steep, it's not too flat. What do you think the simplest slope would be? Okay, we don't want to be steep or flat though. We want to be right. We want to be neutral. Yeah, the easiest slope to have is a 1. What's the easiest y-intercept to have? Probably a 0. So what do you think the parent function is for all linear functions? Y equals 1x plus 0, which normally we just write that as y equals x. There's the parent function for all linear functions. A nice easy slope of 1. It's not too steep, it's not too flat, it's perfect, it's right in the middle. And the y-intercept is a nice easy 0. Oh my gosh, I'm getting so good at drawing lines. There's the y equals x. It's not bad. Okay, now, just like with, remember when we did algebra aerobics with y equals x squared, and if the a got bigger, your arms got skinnier, and if the value of a is a fraction, your arms get wider. Y'all remember that? Are you listening? All right, the same thing happens here with slope. If you change the slope, you're going to change the line. Now, the value of a, remember, controlled up or down, and it controlled wide or narrow. What do you think slope is going to control on a line? It's going to control the incline, the steepness, absolutely. Very good, Mia. You are on a roll today. The slope controls the steepness. What else does it control? It controls one other thing. Okay, then tell us the other answer, Alasia. Ooh, somebody said it. Up or down. Slope will tell you whether you're going up or down and whether you're steep or flat. Okay, so here's y equals x. Let's change the slope. Give me any different slope you want to make it. Y equals 1/2 x. So here comes the problem child. Y equals 1/2 x. What do you think is going to happen to the parent function if I change the slope? It's going to get flatter. Sometimes your slope will get flatter. It got flatter because it became a fraction. What did not change? The y-intercept. I still have a y-intercept of 0, but I'm not going up 1 and over 1 anymore. I'm going up 1 and over 2, up 1 and over 2, up 1 and over 2. That's absolutely going to make the new line flatter. Slope can make you flatter or steeper. How would I make it steeper? Y equals, let's make it 3x. That would absolutely make it steeper. I'm going to do this one in red. Y equals 3x. Now what stayed the same? The y-intercept is still at 0, but this time I'm rising 3 and only running 1. I'm going up 3 and over 1. Look how much steeper that red line got. Okay, so it can either make you flatter or steeper, but it can also change the Direction. We already changed the incline. We made it flat and then we made it steep. How can I change the direction? Put a negative on it. Let's do this one in bright green. How could I change the direction? What would the new equation be? Y equals negative 3x. Okay, good. I'm glad you brought that up. How would this steepness compare with this steepness? The exact same steepness. What's the only thing different? The direction. Okay, so back to the parent, though. It's still got a y-intercept of 0. This time you're going down 3 and over 1. Down 3 and over 1. So the steepness is the same as y equals 3x, but the direction is different. The red and the green line have the same steepness. I didn't draw it perfect. But one's going up and one's going down. Okay, so you need to understand, or you need to be able to describe changes to a parent function, with or without a picture. So if or if you saw this question on a test, how does y equals 5x compare to the parent? It's steeper. Absolutely steeper. Way steeper. Okay? How does y equals negative 1/2 x compare back to the parent? It's flatter and it's going down instead of up. The parent function's going up. So do you understand how slope changes the line? Okay, you three are about to make me crazy. All right, now, what else can we change? I didn't say you were ugly. Okay, back to the parent function of y equals... that one's not as good, is it? Back to the parent function of y equals x. We talked about slope changes. What have we not talked about? Y-intercept changes. What do you think is going to happen to y equals x if I come along and do y equals x plus 3? Yet, what doesn't change? The slope doesn't change. Everything on the line, all the solutions will change, but the whole line gets shifted up 3 spaces. How do those? What do you kind of notice about those lines? How would you just? They're parallel. Absolutely. So fill in the blank for me. Parallel lines have the same slope. Exactly. All right. How would I make it move down? Any number lower than? Y is equal to x minus 3. Any number lower than 0 will move the whole line down. Y equals x minus 3. Again, still has a slope of 1, but the whole parent function moves down 3 spaces. Okay, I still feel like some of you are not really paying attention. Parallel lines have the same... Shh, guys, parallel lines have the same slope, but different y-intercepts. Wow, good. Maybe you are listening. Okay, I want you to compare this to the parent function. Y equals x, and here comes the problem, child. It's a real problem. Y equals negative 1/2 x minus 3. How is that line going to change compared to the parent? It's going to go down instead of up. It's going to get flat instead of a nice slope of 1, and the whole line shifts down 3 spaces. Down instead of up. It's going to go down instead of up. It's getting flatter because the slope is not a 1 anymore. It's a 1/2. Okay, so, and again, we can graph it real easily. The whole thing shifted down 3 spaces. It's shifted directions, going down 1 and over 2. And the fact that the slope became a fraction made it flat. It got flat. It changed directions, and the whole thing shifted down 3 spaces. So you have to be able to describe slope changes and y-intercept changes. What's the parent function of all lines? Y equals x. You got to know that. Yeah, the way it changed is it changed directions. That's why it goes down versus up. It got flatter because it became a fraction, and the whole thing shifted down 3 spaces because of the y-intercept. Okay, that was the second topic. That wasn't too painful, was it? Third topic for today, and this is horizontal and vertical lines, special cases. And this is pretty easy too. Yes, these are special, just like you guys. Which one do you want to do first? vertical. Okay, vertical lines are even more special than horizontal. They are weird. Just like you guys. Okay, vertical lines. Vertical lines are undefined. Say it with me. Vertical lines are undefined. Yes, I did. I said it twice. Okay, let's talk about vertical lines first. And you do need to put this in your notes. This is going to be something you have to do, possibly as soon as tomorrow. Let's talk about everything we know about vertical lines. First of all, the slope is undefined. Absolutely. All vertical lines have the same slope, and that is that they don't have a slope. So all vertical lines have slopes that are undefined. Ladies. So if I tell you that I'm thinking of a line that's got an undefined slope, the first thing that should pop into your head is a vertical line. Now, that is not the equation, though. A vertical line has an equation. And we have to know how to find it, and it's very easy to do. It's the only kind of line that is not a function. Because it fails the vertical line test. It fails its own test. You need to be writing this down. Lizeth, that means you. Okay, so they're not functions. Their slopes are undefined. And the way that their equations work, because they do have equations, it's a relation. All relations can be written like an equation. But we can't put it into our calculator. How do all equations start that we can enter into our calculator? They all start out y equals. Well, these are the outlaw lines. That's why they're so special. They don't follow any rules. They start out x equals. Okay, they don't have y-intercepts unless you're actually at the y-axis. They aren't functions, and they don't even start out like normal equations do, like normal linear equations. They're always x equals some number. Okay, and we've got to find the number that they equal. And then you can either do that from a written description or from a picture. Okay, you want to do one from a picture first? Okay, so here we are on vertical lines. What they have in common is they are not functions. All slopes are always undefined if you're talking about a vertical line. If I give you a picture of a vertical line, you should be able to give me the equation. So let's talk about the equation of this line. It doesn't have a y-intercept. It has an x-intercept. So what's the equation of this blue vertical line? X equals 3. That's the equation of that line. What's the slope of that line? No, not 0. The slope is undefined. Now, a lot of you just looked at the x-intercept and said x equals 3. That's absolutely true. Guess what else is true about every point on this line? All the x's equal 3. So if you forget, because some kids do forget, they don't know if it's x equal a number or y equal a number. And I did this when I was in algebra as well. Sometimes I would have to literally write down some of the points until I saw a pattern. The points on this line all have the same x value, and it's always 3. The equation of that line is x equals 3. Okay, what's the equation of this vertical line? I don't know why, but I'm not good at drawing. Yeah, this vertical line is x equals -2. It doesn't have a y-intercept, it has an x-intercept, and every x value on that line is -2. Are you okay with that? Okay, now this part you need to write down. You won't always be given a picture. Sometimes I might have a written description for you. So if I write a description where I tell you that the slope of the line I'm thinking of is undefined, all I have to give you now is just one point. And it doesn't even have to be a special point. It doesn't have to be an intercept point. The line I'm thinking of has to go through the point 3, 1. That's enough information to write the whole equation. And the equation would be x equals 3. Absolutely. Because on vertical lines, all the x's are the same. So as long as you know one of them, that's what all of them have to be. Let me draw a picture of this. Here's the point 3, 1 right there. Do you agree with that? If I see that it's got an undefined slope, you should know that means vertical. What did that x-intercept end up being? 3. Guess what all the x values are? 3. So the whole equation is x equals 3. So telling me that it's got an undefined slope, that is not telling me the equation. That's just telling me a fact about a vertical line. All right, here's another one. I'm thinking of a line that's got an undefined slope, and it goes through the point -4, 5. What's the equation of that whole line? X equals -4. So even though I didn't give you a special point, I just gave you a random point, -4, +5. I told you that this line has to have an undefined slope. You should know that's got to be vertical. And look what the x-intercept ended up being. -4. All of the x values are -4. Okay, now, this is going back to our quiz that we took. What is the equation of the y-axis? X equals 0. And you have to know that. You might be asked that. The equation of the y-axis, it's a vertical line like all other vertical lines. The y-axis is an outlaw. And it is x equals 0. Okay. What about this? I might also tell you I'm thinking of a line that's vertical. I'm thinking of a random vertical line and it goes through the point 4, 2. What's the equation of that line? X equals 4. It's just like telling you the slope's undefined. Those two things go hand in hand. Vertical lines are undefined. Okay. Now let's move on to horizontal. These do follow the rules. The only thing that's weird about a horizontal line, what's weird about it? Why is it special? The slope is 0. It has a y-intercept. It starts out y equals. It is a function, but all slopes of all horizontal lines always equal 0. So if I tell you I'm thinking of a line with a slope of 0, you should be thinking of a completely flat horizontal line. Does it have a slope? Yes, it does. And it's 0. Does it have an equation? Absolutely. Every type of line has an equation, even the outlaw lines. But these equations are always y equal a number. And it happens to be always the y-intercept. Which, what letter do we use to find the or to denote the y-intercept? B. Basically, all you need to know, though, is any y value on the line. They all have the same y value. So if you know one y value, you can write the equation. Whether I tell you it's the y-intercept or not, it's going to be the same. Okay, so let's do it from a picture. Here comes a red horizontal line. What's the equation of that red line? Yeah, don't just tell me 4. It's y equals 4. What's the y-intercept? 4. What's the slope of that guy? 0. What's every y value on this line? 4. This point is 1, 4, 2, 4, 3, 4, 4, 4. All the y values are 4, including that y-intercept. Okay, here comes another one. Let me move that red line. What's the equation of this pretty horizontal line right here? Y equals -1. Y equals -1. Are you with me? Okay, what if you don't have a picture? I can give you a written description. I am thinking of a line that's got a 0 for a slope. That is a valid slope. That's a number. That doesn't mean it doesn't have a slope. And it happens to go through the point 3, -1. And that's what the mistake some kids make on this. They'll tell me y equals 3. But that's not the y value. What's the y value? -1. So if you're talking about a horizontal line, you need to look at the y values. They're always going to be the same. So let me draw this point. Do you agree that 3, -1 is right here? That's the point 3, -1, right? And I know my slope is 0. You have to know that that means it's completely flat. What did that y-intercept end up being? -1. All the y values on a horizontal line are always the same. So if you know one y value, you should know them all. Okay, and most kids say this is easy, and it is. Here's when it gets hard, when we haven't done it in a couple of days, and we're doing all kinds of linear functions, and I throw in one of these special cases. Right, Dylan? Okay, so you try these two, please. Okay, so I'm thinking of two. Wow, that got big fast. I'm thinking of two lines. One of them is undefined and it goes through 7, -10. I'm also thinking of a line that has a slope of 0 and it goes through 7, -10. What would the equation of this top line be? X equals 7. That's an outlaw line, doesn't follow any rules. What would the equation of this bottom one be? Y equals negative 10. So you got to know the difference. You got to know when you just need one Y and when you just need one X. I would have to give you some kind of description. Yeah, I would have to tell you something about the slope, or I'd have to tell you it's a vertical line. Just knowing one point is not enough. You got to know something else. Okay, so are we good with that? Alright, so what's the equation of this line? Don't just tell me negative 3. X equals negative 3. What's the equation of this line? X equals 4. What's the equation of this outlaw? X equals 0. What do all those slopes have in common? They are all undefined. Alright, what's the equation of this horizontal line? Y equals 3. What's the equation of this horizontal line? What's the equation of this horizontal line? So what's the equation of the x-axis? Y equals 0. It's a horizontal line like all others. Okay, well that was pretty much our 3 lessons. Now, your homework, which I want you to get it out. I want you to look at these pages. It's page 319 to 320. We are doing 1 through 10, but I'm going to let you skip one of them. And I want to look at it, and I want you to tell me why I'm going to let you skip it. Please don't write in the booklet at all. We will eventually do number 9, but as of right now, we don't know how to do number 9. So you can skip number 9, and we're also not doing 11 or 12. We're just doing 1 through 10, and I'm going to let you skip number 9. Now, some of them have more than one picture. So let's look at those 2 pages. Very good. Okay, let's look at this together. Now, these copies aren't great, but I think you can identify the slope and the y-intercept. I tried to put nice, big, huge dots for you so you could count out the slope and the y-intercept. Please don't use your pencil to count it out, though, because then you end up marking on my book. Use your finger if you need to actually... So please don't do that. Let's do number 1 together. Yeah, we are going to grade the homework in just a minute. Okay, but I think you can see the 2 points that you need. Here's what number 1 looks like. Who can tell me the equation for number 1? Now, don't just tell me negative. First of all, this isn't negative. This line's going up. Look at it. It's definitely going up, and it's going up really steeply. Y equals 5x minus 3. That's the equation of number 1. It's 5x. I mean, the slope is 5 because I'm going to go up 1, 2, 3, 4, 5, and over 1. And the y-intercept is negative 3. That's all you have to do. So the homework's real easy. Now you got to write the equation. Some kids are just telling me 5. Okay, they're finding the slope, but that's not an equation. It should look like this. Y equals 5x minus 3 with the slope in its right position and the y-intercept in its right position. We're putting it in slope-intercept form. Now, real quickly, though, I want you to somebody already figured it out. Look at number 9 and see if you can tell me why I'm letting you skip it. Because the y-intercept is not a nice whole number. Now, we can make a guess, but I'm not even going to make you do that. We will learn how to do this, but this requires some skills, some math. You got to actually do some math here. You cannot always tell from a picture what the equation is. When can you not tell? When the y-intercept is not a whole number. This requires you to do some figuring. Some computing. Okay, so we'll come back to that, but I'm not going to make you do that one. All the others have nice whole number y-intercepts. Now, another thing I want to point out. Look at number 7. How many answers should you give me for number 7? 2. And I numbered them. There's a 7, 1, and there's a 7, 2. Do you see what I'm talking about? What do you notice about those lines? They're parallel. Guess what's going to be the same about them? They should have the same slope. Parallel lines have the same slope. How many answers should you have for number 8? 3. 3. So number 8 actually has 3 parts. There's an 8-1, an 8-2, and an 8-3. What do you notice about all those lines? They're parallel. Guess what? They should all have the same slope. Okay, so that's your homework. You have to write the equation. The homework should not take long. It's just identifying slope and y-intercept from a picture and writing the equation. All right, that's it for your lessons. Now we're going to grade the homework. Get your homework out.